Induced nuclear reactions. Hello, I am Mara Carlene of Santos from BSE Designs 3A, your presenter for today. Points to discuss: definition, discovery, challenges, and two techniques. What is an induced nuclear reaction? An induced nuclear reaction is defined as a change in the nucleus of an atom brought about by subjecting it to an impact with other nuclei of the same or different type. An impact with or bombardment by subatomic particles or high-energy electromagnetic radiation. What is nuclear reaction? Change in the identity or characteristics of an atomic nucleus induced by bombarding it with an energetic particle. The bombarding particle may be an alpha particle, gamma ray photon, neutron, proton, heavy ions, any particle with one or more units of electric charge and a mass exceeding that of the helium-4 nucleus, alpha particle. Special types of accelerators are capable of producing fairly intense, high-energy beams of heavy ions which are used in basic research, as in the production of synthetic transuranium elements. Example given, helium, atomic number of 105. In any case, the bombarding particle must have enough energy to approach the positively charged nucleus to within range of the strong nuclear force. A typical nuclear reaction involves two reacting particles, a heavy target nucleus and a light bombarding particle. Produces two new particles, a heavier product nucleus, and a lighter ejected particle. Discovery. In the first observed nuclear reaction in 1919, Ernest Rutherford bombarded nitrogen with alpha particles and identified the ejected lighter particles as hydrogen nuclei or protons, and the product nuclei as a rare oxygen isotope. Earlier, Rutherford learned to create hydrogen nuclei as a type of radiation produced as a yield of the impact of alpha particles on hydrogen gas. These nuclei were recognized by their unique penetration signature in air and their appearance in scintillation detectors. These experiments began when Rutherford noticed that when alpha particles were shot into air, mostly nitrogen, his scintillation detectors displayed the signatures of typical hydrogen nuclei as a product. After experimentation, Rutherford traced the reaction to the nitrogen in air and found that the effect was longer or larger when alphas were produced into pure nitrogen gas. Rutherford determined that the only possible source of this hydrogen was the nitrogen, and therefore, nitrogen must contain hydrogen nuclei. One hydrogen nucleus was knocked off by the impact of the alpha particle, producing oxygen -17 in the process. This was the first reported nuclear reaction. In the first nuclear reaction produced by artificially accelerated particles in 1932, the English physicists J.D. Cockcroft and E.T.S. Bolton bombarded lithium with accelerated protons and thereby produced two helium nuclei, or alpha particles. As it has become possible to accelerate charged particles to increasingly greater energy, many high-energy nuclear reactions have been observed that produce a variety of subatomic particles called mesons, baryons, and resonance particles. Examples. Famous example, atom bomb or nuclear reaction. We are forcing a nuclear reaction to take place artificially and through that creating a tremendous amount of energy. Atom bomb was made of plutonium and made artificially. We have sample of boron-10 and you could expose it to the alpha particles. And alpha particles could come from some other radioactive source, and during the process, you could actually change boron to nitrogen. This goes against to the law of conservation of matter, but it works with nuclear reactions as long as things are balanced, meaning you account this alpha particle on one side and the neutron on the other side. We aren't creating or destroying anything here. Sometimes, you can change nuclei to nuclei that are unstable. The new nuclei will undergo to the radioactive decay. Another example is nitrogen-14 in the air bombarding it with a neutron, creating carbon-14, and carbon-14 will decay slowly over time. It's occurring in our upper atmosphere. Uranium-238 atom interacts with a neutron and it becomes uranium-239. This is considered as an induced nuclear reaction because we shock the neutron at it and change the actual movements once uranium is changed. And have the uranium-239, all you're going to do is changing the isotope, which means changing its stability. Sometimes, we do this because we want it to be actually be into something else we want. But we were in uranium-238, which is relatively stable. Uranium-239 will relatively quickly naturally decay using beta decay. So it will become Neptunium-239, and then Neptunium-239 naturally also decays relatively quickly into Plutonium-239, which is a usual element that we use into nuclear reactors. The other last two example is an example of spontaneous nuclear reaction because they're just naturally decay of their own. Challenges. Neutrons. Common source of radiation where we use neutrons to convert nitrogen-14 to carbon-14. Like bullets, they zip past other nuclei very quickly. Neutrons must be slowed down in order for capture to be effective. Moderator. Material used to slow down neutrons. With charged particles, overcome repulsion by the nucleus. This can be done by speeding them up and providing them with enough energy. 2 techniques. Cyclotron is a circular system where we're using the strong magnetic fields to essentially start out with a particle in the center and speed it up using magnetic fields all the way until it ejects out in open port. Linear accelerator. Linear accelerator uses electric current to help speed up these charged particles and eject them through a series of tubes and fling them out essentially at the target. Thanks for watching. I hope you learned something today. If you have any questions, you can drop your questions in the comment box and I'll answer it to the best of my knowledge. Stay safe, everyone!